turned it on. Make sure the mic isn't silent this time. Oh, I have to do that too. Hold on. Okay. We're going to... Boom. Now we're going to edit this browser source. Bam. There we go. Okie dokie. Let's move over. Whoosh. There we go. Alright. Now we're going to be doing some math. This time, to keep it simple, I'll just throw in a few songs to start. So let's see here. You know what? Oh, actually, better idea. Let's throw on some Nintendo music. Hold on. I sneeze. Thank you. Okay, now we're starting. Okay. I need it too. Can I get it to... Let's see. Will it detect? Or do I have to restart Tuna for that? Oh, it's because what I need to do is here, it's going to be Windows Media Control. I'm going to stop, and we're going to start it again. There we go. Because now what that's going to do, it's going to take what's playing, and it'll put that there. So I don't have to do like a weird window title thingy. Alright. It's gonna be the limit. So, let me get the drawing pad out. I charged it yesterday. Alright. Okay, so I believe the formula for a derivative, if I remember, is going to be the limit of f of x plus h minus, I think it's f of x over h as h approaches 0. So that means in this case it would be the limit of, so e to the x plus h minus e to the x over h, which looks like this one. What's the difference? Well, that says e. Which one is it? Okay, I was worried. I have a fear. add artists to this. Hold on. Now, hopefully... Oh, that's okay. Maybe it just doesn't detect them. That's not a huge deal. But back to this, I thought it would be this. Or it might just be x instead of f of x. In that case, I think this would be the answer. It's not. Huh? Okay, so there's... minus f of x. Yes. Do I need to know both of them? I'm like 100% sure we didn't learn both of them before. So in this case, it would be limit as h approaches 0 of e to the x minus e to the t over or in this case it would be h. Or no, you got okay, hold on. I hate it when they change the variables. Okay. I think I get it. Okay, let's try this again. Maybe with a more entertaining song. Does it put it on random? We're about to see. Okay, I think it does. Okay. So let's keep this formula as h approaches 0 of f(x) plus h minus f of x over h. And in this case, x equals pi over 2. So first, let's do this. So it's going to be the limit as h of 0, as h approaches 0, of sine x plus h minus sine of x over h. Or it wants us to do this one. Sine of x minus sine of h over x minus h. Okay, hold on. I swear you do not need to know both of those formulas. We get average rate of change. Yeah, it's just f of x plus h minus f of x over h. You don't have to know the other one. Next, and then eventually you get power roll, so it doesn't even matter. Oh, I guess, okay, so there is the alternate form of the derivative. F of x minus f of c, x minus c. So I guess in this case, The sine of pi is 0, yeah. It's one of these two. Alright, next lesson. I forgot if there's a specific way to do this. I'm gonna say, let's do, I'm gonna pretend I did that inversely because I did, so my guess is 4. Okay. Okay, so I am doing it right. Just use your algebraic intuition. These are flipped, by the way. I keep putting them on the wrong side. Thinking real hard here. Sorry, I was thinking real hard. I think I'm gonna need a new pen tip soon. And I might buy one of those stickers that you put on top of these. Because supposedly they help protect your thingy. This is a little more than 5. Oh my goodness, I keep putting it on the wrong side. A little less than 4. It's not differentiable at 0. I'm pretty sure it's differentiable everywhere else though, so just 0, yeah. It'd be 1. I think 5 is differentiable. Nope, it has to be continuous? Okay, let's see why. Okay, wherever it's not continuous, wherever it has a vertical tangent line or a sharp turn, like a, think of like a V. Okay, we got a lot of it here. We got -4, we got -5, we got 0. We got -2 for 2 reasons. We got 2. And we got 4. 0's not, because it's a horizontal flat line's okay, just not vertical. Because we can say 0. And that's where we get into like degrees of differentiating, like like prime, double prime, triple prime, or something like that. I forgot what it was called. It's somewhere in here. I don't want to listen to Dr. Schultz. Is it? Okay. Need to make sure I have a different keyboard. Sounds a lot better. Not this one, but this one is also a really nice one. It has a little screen on it. Actually, if you turn it on, it is definitely like one of those Chinese brands, which is fine. It's just that the software has low English support, that sort of thing. You can put your own GIFs on it. Come on. There we go. So you can put your own GIFs on it. So isn't that cute? Alright. I also just learned on the placement exam, I won't be allowed to use a calculator. I can only use a dumb calculator, so I won't be using this for the rest of our time. That also means certain problems will be impossible. So, yeah. I guess I won't have to worry about those ones specifically then. I forgot I was doing that earlier. Okay. The graph has a vertical tangent at x equals 2. Yeah. I thought that was obvious just by looking at it. Function given below, continuous. Is the function continuous and differentiable? Well, let's check. Alright, now here is where we talk about it. So, differentiability implies continuity, right? But continuity does not imply differentiability. Now what you can do here is you can check the slopes. Technically the way to do it, you could derive, like for example, this would just be 2x, and the other one would be 14x minus 12, so I don't think they're differentiable. We can check if they're continuous. You just have to plug in the point. It's going to be -5 and -5. So actually I clicked the wrong one. I think it's continuous but not differentiable. Differentiable but not continuous. Both continuous and differentiable. Okay, so my reasoning is wrong. Let's see. So we check. So they're continuous. Would you get -5? Oh, because they both need to approach -5, I guess. Alright. See, we're learning. Okay, so we'll check for continuity first. What did I do here? This is the same thing. I'm taking a look at my notes in here. See, this is why my teacher's the best. You know what would be fun? It'd be a lot to ask. I could ask, hey, could I have a packet of all your homeworks so I can just do extra practice? maybe in college then. That might not be a horrible idea because my teacher has great resources. Okay. 8 versus... Definitely not 8. What is that? If it's not continuous, it can't be differentiable, right? It's going to be -4, by the way, so it's not continuous. I might as well check, but I'm pretty sure that's impossible. Okay, so I did use it, and I just don't know what I'm talking about. So the limit as x approaches -4, because we're checking, I guess, a specific formula. So it's going to be, or in this case it would be g, f of x minus f of t, or -4, over x plus 4. If we're doing from the left, it would be this would be so much easier to do on paper. So we're left with this. It's going to be -4. So -4 on this side. Now let's check this side. Yeah, let's just fill in the number. I can do it in my head. If it's -4, it's going to be 16 minus 20, so -4. And then so this becomes... You can simplify this into x minus 4, x minus 1. X plus 4, x plus 1, sorry. So it'll be x plus 1 over 1. So then it's just going to be -5. So it's neither. If it's not continuous, it can't be differentiable. There's a big Among Us on my paper. I don't know how to describe it. That's just what happened. Okay, we have differential rules. Now we learned the power rule, constant multiple rule. Let's see See, now deriving has become infinitely easier, but you can't forget, you know, your formula. Stop turning low line compensation on. Why does it? I don't know why it keeps doing that. If you keep low light compensation on, then sometimes the camera will just slow down. Otherwise, now it'll just keep constant frame rate. Also, I just realized I forgot to turn the frame rate down. That's an oopsies for me. Okay, at 4, it's going to be 11 versus 11. Alright, now we'll check. So the limit as x approaches 4 from the left of 2x plus 3 minus, we'll just plug it in now. Actually, you know what it's going to be because it's right here. Divided by x minus 4. Right, and so on top we're left with 2x minus 8, x minus 4. This simplifies to 2, trust. And so, okay, so this is 2 on this side. So now we'll check the limit on as it approaches 4 from the right. X squared minus 5. Then you have 11 over x minus 4. So it's minus. So you're going to be x squared minus 16 over x minus 4. Trust me, when this simplifies to x plus 4, then you're left with 8. So it's continuous. Don't do that. It's continuous, but not differentiable. Because the left and right limits don't equal each other. Okay, I'm going to be right back. Alright, we're back. Okay, it's a 9 versus 9. Now let's check. So the limit as x approaches 3 from the left side, x squared minus 9 for x minus 3. This simplifies to x plus 3, which is going to be 6. Now, the limit as x approaches 3 from the right equals to 6x minus 9 minus 9 over x minus 3. Now this is going to simplify into 6x minus 18 over x minus 3. And trust me when I say that this is 6. So this is both differentiable, continuous, and differentiable. Alright, gonna do this again. Let's take a looky here. The function below, let's just plug it in first. Negative 4 plus 12 is going to be 8 versus 12 minus 10, that's 2. Okay, let's double check this one. Negative 4 plus 6. Sorry, I don't know where I got 12. Okay, so they're both 2. So now we'll check the limit as x approaches 2 from the left. Negative x squared plus 3x. Since it's here, we'll just do it. Minus 2 over x minus 2. This will simplify to, let's just do negative 1 times x. Okay, this is negative 2. It's going to be positive 2, but negative 3. So negative 2 x minus 1 over x minus 2. These cancel out. So it's going to be negative x plus 1. So then we're left with 1 for this limit. Now we have the limit as x approaches 2 from the right. So 3x squared minus 10. We already know what the answer is. Minus 2 over x minus 2. Oh, actually, let's do this even quicker. Let's just say 12. Okay, this is a little more complicated. No, it's not, actually. So we're going to take out a 3. X squared minus 4. Minus 2. Just hang with me here. It's going to be 3x plus 2. Alright. Plug in 2. We get 12. Not the same thing. So it's continuous, but not differentiable. Boom. Alright, now we take our mini quiz. We can estimate it's gonna be pretty steep. Okay, not differentiable at 2. I think that's it. Okay. Let's check here. Sweaty. You know what? I should have got a drawing glove. That's what I wanted to remember to do, because then it makes you glide a whole lot easier. So let's see here. Okay, first one is 0. Second one is 0. So now we'll just check the limits. The limit as x approaches 0 from the left is going to be, it's just 2x squared minus x over x. So then this implies just 2x minus 1, so it's going to be negative 1. So now the limit as x approaches 0 from the right side is going to be negative x over x, which is just negative 1. So yeah, it's continuous and differentiable. Wait, but wouldn't... I gotta think about that. Okay. What's this one? Boom. Find this. What is the slope? Okay. So we have 5 minus 1, and we're gonna have 0.5 to the 5th minus to the negative 5th is 0.5 to the negative 1. So basically this is just going to be 1 over 0.5 here minus 1 over 0.5. And then so what this simplifies to, or actually since these are the same base, no, that's multiplication. So basically this is just 1 over 1 over 2 to the 5th, which just equals 1 over... I'm pretty sure this is just 2 to the 5th minus 2 to the 1st. 2, 4, 8, 16, 32. 31, 30, 4. I'm pretty sure. Yeah. Hi, Brantford. How you doing? Oh, my nose itchy. Should have tuned in yesterday. I did a whole 3 hours of work and then 3 hours of not work. What is the best estimate? Okay, we're gonna put it on the right side this time. Pretty sure it's this one. Yeah, there we go. Okie dokie. We're moving on. Oh, I never finished updating that game. And once we finish this, I want to reward myself with 35 waves. It goes by really quickly, I promise. We might be able to get this done really quickly. Okay, now we can just do power roll. Oh, this is gonna be awesome. This power roll, you can do in your head. I forgot some of the later rolls, so we'll have to pay attention there, but that'll be awesome. Also, I really like implicit differentiation. I think it's cool. Something I didn't understand is how some people were having a huge problem with it, but really all it is just separating the X and Y's together. So it's going to be 1/3. Okay, well, let's write this down. It's going to be, so 1/3 times 1 over x to the 2/3. So basically 1/3 times 1 to the cube root of 64, which is 4. So it's going to be 1/12. If you're confused how I got that answer, sorry I didn't show my work. Can people stop pinging me? Oh, Squim Jim has a new video. New TF2 lore. Sweet. Okay. What's going on in here? Ooh. Awesome. In here, is that my ping? That's my ping. Yeah. Someone was playing Fortnite yesterday. I wonder who. I actually could see, I just didn't pay attention. I just saw the big F, you know. Okay, it's gonna be 2/3. I wonder how they would have written. Oh, like this, or whatever the freak I just wrote. Okay, it's going to be -11 over x to the 12th. Who texting me right now? Okay, so my friends are really bad at planning stuff, I guess. This is going to be equivalent to, so -10 times 1 over x to the 11th. This is going to be which is going to be negative 10. All right, next exercise. Okay, so it's easier to think of it like this, because that's equal, right? And then so you have negative 4 times 1 over x to the 5th. Now if you do it at 2, x to the 5th is 32, so negative 4 over 32 equals negative 1 over 8. Okay. Once you get to a certain point, you can just start doing these in your head. Like this is going to be negative 8 over x to the 9th. That's what this is. It makes sense. You can do out the full version, but then you recognize the pattern. It's good to know, you know, the underlying way, not just like, oh, so this correlates to this. Like, you know, knowing your times tables. Like for example, if you know your times tables, you probably just know that 3 times 9 is 27. But then if you know it conceptually, then you would think like, oh, so this is 9 groups of 3. Not necessarily that these two numbers, when put together, make 27. You know what I mean? So it's good to know things at a conceptual level. I just had a big brain idea. Hold on. I'm going to try something. This might forever fix the issue we're having down there. Okay, so Spotify doesn't count as a media player. Or VLC doesn't count as a media player. Because that makes sense. Tuna don't recognize VLC. Okay, so never mind. But you do recognize Spotify, huh? Oh well, whatever. We'll just go back. Okay. Okay, now... Oh. Oh my goodness. These... You can't say both when there's 2 different times for an event. Guys. Come on. Can we lock in, please? Okay. Anyways, you can rewrite this as x to the thirds. So then what you do, 2/3 times x to the negative 1/3. Because what you do, if you have x to the n, so d dx, this goes to... This becomes nx to the n minus 1. That's basically the power rule. This is a little unreadable, so it's just going to be 2/3 and the cube root of x. That's just what it is. So 2 over 3x raised to the 1 over 3. I'm just going to write it like this because I don't feel like clicking that tab. Okay, now we plug in a value. So this is going to be 4/3 times the cube root of x. So it's just going to be 4/3 because it's 1. Okay, so I did this wrong. Is it not? Because if it's the to the 4th, it's going to be 4 over 3 times x to the 1/3, which is not 1. Hold on, I'm probably missing something here. Because this is equal. It's not equal to 3 over 4. It is equal to 3 over 4. I swapped my numbers like Jimmy McGill. Okay, let's try this one. So let's Okay, negative 3 times x to the negative 4th. So this is going to be negative 3 over x to the 4th, which then if we go forward, negative 3, that's going to be 36, no, 9 times 9, so 81, which then equals, so negative 1 over, if we divide that by 3, let's see, 27, so negative 1 over 27. Okay. See, mistakes are part of the journey. I'm never doing dinner with anyone else again. If we try to find the derivative of 7 minus 5x using basic differentiation rules. I don't think there's a mistake, but is this how you would do it? Oh, well, actually, you need to subtract. Step 1, you should be subtracting. I guess, okay, so that looks like the long, complicated way to do it. AKA the way, it's like proof. That's what it is. The answer should not be 0. Okay. Let's see. I was about to say, can we get this done in under an hour? No, we're at the 50-minute mark already. Oh, okay. Now I have to go. Alright, just talking with my mom. Okay. Okay, so if h prime of x, it's going to equal 4g prime of x plus 5hx plus, here, just to show all the numbers. This equals 0, by the way. So it's just going to be 0 plus negative 105, I think. I hope there isn't a rule I missed. Nope. Okay. I'm not gonna check that because I'm not the host. Okay. So the derivative of this, it's going to be negative 2 f prime of x plus 5 plus 5g prime of x. And then, you know, the derivative of a constant is 0. And then so we're going to do it at 2. So it's going to be negative 2 times negative 5. That looks like a plus. Can't correct everything with another line. Plus 5, 4. So this equals 30, I'm pretty sure. Yeah. Let G be defined. Okay. So G prime is just going to equal negative 4 f to the x plus 3gx. So my g's look like 6s, and that's a problem sometimes. It's been a problem, I think, in certain math contexts and science, because those are usually where numbers and words mix. Oh, probably the FRQs. I'm sure I had a problem with that at some point. It's gonna equal 12. I don't feel like showing my work this time, so I'm just gonna do it in my head. It's gonna be negative 3 minus 3, negative 3, which equals negative 3 plus 9, so 6. I skipped one. There. This one is easy because if you remember, if you saw the thing earlier, you treat each one of these nomials as an individual. And you can just say 20 minus 1. So you can think of it, the same rule applies to x. It's not like a special case. This is x to the 1, right? So then if you derive it, then it becomes 1 times x to the 1 minus 1, which equals x to the 0, and this equals 1, so it's just 1. I missed that circle really badly. Okay. I appreciate punctuality, just so you know. Not punctuation, being punctual. Stop that. I'm gonna change that. Hold on. Maybe I can set this up later, but I'm not doing it right now. It's too annoying. Emojis, screenshot, options, workstation, AI integration. Yeah, we're not doing that, okay? Okay, give me the tour actually. Okay. All right. What does this do? Actually, I can take a guess what that does. Let's see. I like Windows Explorer. Ooh. I need to get rid of these. What if we learned, or what if we had it launch VLC? Oh, that's an ugly logo though. Can we edit the icon? Okay, that looks better. Okay. That's cool. Alright. There we go. And that pauses, and that plays. There we go. Alright, now we can get back to our more important duties. Okay, so to do this one, 3x squared minus 8x plus 3. Okay, this is going to be 75 minus 40 plus 3, aka 35 plus 3. Okay. Shoot, what just popped up? Okay, we're gonna take a look here. I did not pause in time. Hold on, I'm looking back. I got a badge, apparently. Cascade badge? Whatever that means. I guess I did something good. A lot of skills? Sure. Okay. Mixed and positive. So usually this would be tough, but not for me because I'm awesome sauce. Negative 18 over x to the 7th plus 4 over x to the 5th. Oh, okay, so negative 18 over x to the 7th. Can you put the negative there, please? Thank you. Now this is going to be plus 4 over x to the 5th. I could show my work, but I don't need to. Boom. That's what we call internal maths. I'm very slow compared to smart people. Okay. Let me do my fractions in peace. Okay. No. Okay. Yeah. That's what we call success. The keys to suckies. Back's killing me right now. Do the following. There's a line tangent. To find the tangent line, what you can do is you take the derivative. So think of it like this. So the first derivative of a line checks your slope. This is the tangent slope. The second one checks concavity. I think that's what it is. Like, is it concave up? Is it concave down? Or is it like a linear line? So you can think of it like this. Let's say you have a graph, right? And it goes like this. You take the derivative here, right? It's a little curve. Then your derivative line, so let's just say this is f, and then f prime, is going to look, your derivative graph, like hypothetically, because we can see, it's going to look like this, right? Because even though the slope is positive, over time, it's getting closer to 0. And then if you take a double prime, we're going to check concavity, we see that it's negative, because so positive would be looking like this, so going up, and then negative is flat, going like that. So then your next graph would just look like that, something like, or it'd actually be in the negatives. So your line would look something like that. I'm pretty sure. We'll reveal those. I'm sure we'll review those sooner than later. But for now, that's just what this is. So I'll just take the tangent for now, because that's all we need to do. We plug in 1. Okay. And this solves for y, so our slope is 2. No, we just solved for our slope. So now we need to solve for y, I think. Oh, we also have to solve for that too. Oh, actually, no, we got this. No, we don't. Hold on. How am I stuck here? This is like the easiest part. We found the slope. Oh, we can find it. Okay, so we can find the coordinate. It's going to be 1. So now we have 1 equals, so b is -1. Alright. You didn't understand the process there, that's fine. I kind of went around in circles for a second before I could figure it out. So let's find our coordinates first. So let's see. This is going to be 9 minus 15 minus 3, aka -6 minus 3. So this is going to be -9. So this is our point. So it's going to be, now we just need to plug it into the y equals mx plus b. So we have, it's going to be -9 equals, we'll find our m in a second. And we're going to solve for b. But first, let's find the tangent. 2x plus 5. Plug in -3. -6 plus 5 equals -1. So -1. So this is going to be -9 equals 3 plus b. Subtract both b equals -12. So now it's going to be y equals -x minus 12. -x minus 12. Yeah, don't know where the plus came from. All right, that would have been close. That would have been bad if I got that wrong, and embarrassing for Moy. Okay, so first solve for our point. 8, 20. Okay. Four, 12. Minus 20 equals -8. Boom. I really gotta wipe this down. You can see, and it's a little messy. Hold on. This is very clearly for the right hand. Unless it's reversible. Oh, I guess it is reversible. Ergonomic, comfortably fits your hand. I would hope it's a glove. Okay, there you go. Okay, so our point is -3. 18. -3. -12. Okay, 4x plus 7. -12 plus 7 equals -5. Okay, so -12 equals -5. -3 plus b. -12 equals 15 plus b. b equals -27. So y equals -5x minus 27. Y equals -5x minus 27. Okay. I love the DS game. It's just 3. Negative. Okay, wait, now I'm curious. How do they know that? You can actually, we'll simplify this. This gets me 3/2. Okay. -1, 2, 0. One, okay. So b equals 1, so it's going to be y equals x plus 1. Okay. No. There. There. I hope that has been out for a while. I hate this stupid mic. Oh. this is going to be 2 over 3. So it's going to be 2, 3, x raised fifth. There. Okay. Derivatives. So this is the hard thing to remember. Oh, this product rule.
Gonna start.
High low, low high. Yeah, high low, low high, high low, low square. Okay, here are the trig function derivatives. I had these memorized at some point. And it... Oh. Yeah, this guy's Japanese. You can tell by the slash. Okay, so... d dx sine equals negative cosine x. You can think of it as like anything that starts with an s becomes negative. And then the derivative of cosine x equals sine x. I lied. Anything starting with a c. I got it backwards. Right? And then for tangent, I think it equals cotangent. Or secant squared. Sure. Okay, now for the inverse trig functions. The derivative of cosecant equals negative cosecant and then cotangent. The derivative for secant equals secant tan. And then the derivative for cotangent equals negative cosecant squared. How did they figure that out? Beats me. Okay, the important thing to know. Okay, so anything that starts with a C will result in a negative number. That's C, or result in negative. So sine to cosine is positive, but cosine to sine is negative. And then see, then you can go in this cycle. So then it'd be negative cosine and then sine. And it goes like in a loop. It's a four-part cycle. So in this case, it's going to be 2 minus 3 cosine x. This one's going to be negative 5 cosine 5 cosine x plus 2x. Negative 3 sine x. Hey. Negative 3 sine x plus 8x. $15x squared plus 6 sine x. Okay. Gonna take a quickie break. I'll be right back. Apologies, had something to do. It's raining like crazy right now, and I hate me babies. I think it's gonna be. Yeah, okay, I remember. The cool thing about e to the x is that it always stays the same even through derivation. Oh, what are you trying to control Z? Wait, uh-oh, hold on. Hold on, I want to make sure nothing accidentally just got deleted. Can you not delete the... Okay, hold on. Okay, I didn't. Okay, I'm gonna move these over to my to my regular drive. This is driving me nuts. Get it? Okay. Let's just finish this unit up and then I'm gonna end it because I do have an event. So this is just a a quicker one. Even though I was gone for 20 minutes. That was product rule. Okay. please. With a cleaner look. Okay. Rewrite this out. Okay. How long has this been muted? Super upset. See, what I would need is like, I need this audio mixer. Just like stay here the whole time so I can see like, hey, is it going up? Actually, don't know which way I prefer. I prefer this way. Oops. 8 minus 12. Yeah. Four, 6. Y equals 6x minus 16. Choose not to differentiable here. It is here, not here, not here. -7. Do you hear the Super Mario motif kind of sprinkled in there? Phew. Thinking negative 1/3. No. Oh, what am I doing? I flipped it even though I didn't need to. I have to do this again. Because I would like 100. It looks good. What was that? Oh.
Here we go, off the rails. Don't you know it's time to raise our sails? It's freedom like you never knew. Don't need bags or a pass. Say the word, I'll be there in a flash. You could say my hat is off to you. Oh, we can zoom all the way to the moon. On this great wide wacky world. Jump with me, grab coins with me, oh yeah. It's time to jump up in the air. Jump up, don't be scared. Jump up and your cares will soar away.
It was the first one too.
Let your toes begin to tap. This rhythm is a power show. Don't forget you're the superstar. No one else can make it this far. But go through that stash. Now you've got panache. Oh, let's do the Odyssey. It's time to jump up in the air. Jump up, don't be scared. Jump up and your cares will soar away. And if the dark clouds start to swirl, don't fear, don't shed a tear, 'cause
I think I see where I'm getting confused.
now listen, all you boys and girls all around the world, don't be afraid to get up and move. You know that we're all superstars. We're the ones who made it this far. Put a smile on that face. There's no time to waste, so let's do the Odyssey.
What the? Four to 19. One moment, taking a break. Okay, never mind. No! Stupid keyboard. Also, this is literally the answer. I just put a few more parentheses. This is stupid. Oh my goodness. I'm gonna try to finish this in 12 minutes. Hold on. Minus 13x minus 9. Okay. We finished before the 3-hour mark. Okay. This unit is over. What we're going to do now is we're going to work on the book, because I do have more time than I thought I would, so we'll work on the book. This thing, which means I'm going to get the crap camera out. Okay. So you see this is short, but then Unit 6 is pretty long. Then Unit 10 is just awful. I think Unit 9 sucks. So Units 9 and 10 suck. Unit 6 is long. I think that's the roadmap from here. I think what they want me to do. They want me to do where it's limb. Okay, I know they want me to do the whole limb thing, but I know how to. Let's see, how long is this? Okay, not that long. 20-something pages, and most of it's explanations, and we know how to do it already. If I need to, I'll take a peek. You know what I've decided? I'm tired. I'm gonna do this tomorrow. Okay, so that's it for today. Thanks for watching. We've done with Unit 2. We're gonna go on to Unit 3 tomorrow once we finish that book. Alright, bye-bye.